Welcome back everyone to a session on Unix programming. In our previous lecture video, we have learned about System 5 IPC methods, and we have seen similar features among these IPC structures. So when I talk about each of these structure, I am talking about message queues, semaphore, and shared memory. We have seen features like identifiers and keys, the permission structure that is common among these three IPC structure. Then we have seen the advantages and disadvantages of using the System 5 IPC methods over pipes and FIFOs, right? And in today's session, we will look into each one of these IPC mechanisms in details, starting with the first one, which is message queues. Now let us see what exactly a message queue is and what are the various functions that can be called with respect to message queue. Message queue is actually a linked list of messages stored within the kernel, and it is identified by a message queue identifier. So even though it is named as queue, it is actually a linked list of messages. And with our knowledge of data structure, we know what are the advantages of using linked list over a queue, right? Which we will be exploring with respect to message queues. We will look into that advantages later. And let us talk about some of the functions. A new queue, a new queue is created, or an existing queue is opened by using the function msgget, msgget, msgget. Okay, and new messages are added to the end of the queue by using the function msgsnd. Okay, and every message has a positive long integer type field, a non-negative length, and the actual data bytes, all of which are specified to the message end when the message all of which are specified to the message send when the message is added to the queue. And this is with respect to the receiver of the message. The messages are fetched from the queue by using the function message receive. So this is used by the process which want to read from the message. Okay, and we don't have to fetch the message in the order of first in first out. So instead, the receiver can fetch the messages based on their type field. So this is the advantage of using the message queue over FIFO and pipes. Now let us look into the data structure associated with the queue. So each queue has a following message queue ID data structure, and these are the various members of this particular data structure. Okay, it's a structure, and the first member is again a structure itself, right? IPC perm. And we have already seen in our previous lecture video what exactly this IPC permission structure means, right? And this is related to the various permissions and ownership regarding the IPC structure, and this is common with respect to message queues, semaphore, and shared memory. Okay, let us come to the next one, message queue number. So this represents the number of messages on the queue. Okay, message queue bytes, this represents the maximum number of bytes on the queue. Message last send PID. Okay, so this is with respect to the process. Okay, so this holds the PID of the process that had made use of the message send function to send some message into the queue. Okay, and it belongs to the process that has made use of the message send function last. Okay, so it holds the PID of the last message send process, and this is no brainer. So if this belongs to the last sender, this message LRPID is associated with the process that had made use of message receive function at the last. Okay, so it holds the PID of the last message receive process. The next one is message S time. This holds the time at which the last message send function was used, and this is the time at which the last message receive was called. Okay, last message receive was message receive was called. And finally, message underscore C time represents the last change time with respect to the message. So this is about the various members of the data of the structure message queue ID data structure. Okay. The first function, normally called as msgget function. So it is either, as I previously said, it is either used to open an existing queue or to create a new queue. Of course, before I can perform any sending of messages or receiving any messages from the message queue, first I need to create a queue, isn't it? So that task is accomplished by using the msgget function, which is used to create a new queue or open an existing queue. Okay, and its syntax goes like this. Okay, so it obviously returns an integer value and it takes two arguments, key and flag. So about the key, we have learnt in our previous lecture video how key is generated and how it is converted into an identifier. And very soon we will be looking what is the significance of this flag. Okay, of course it returns a message queue ID if the function is successful and -1 on error. This queue ID is later used by other functions like message send and message receive and also message control. We will be looking into those functions later. Yeah, when a new queue is created, the following members of message queue ID data structure, which we have spoken previously, are initialized. So some of the members of this data structures are initialized. The first one is IPC permission structure is initialized, and the mode members of this structure is set to the corresponding permission bits of the flag that is mentioned here. Okay, and what are the mode members, what are the values it takes? To recall that, we have to go to the previous lecture video where we have learnt about IPC permission structure and the mode member values, right? What are the values the mode can take that can assign a value or that can assign a permission to the owner, group and others. Okay, so we can recall all those details by looking into the previous lecture video. Yes, and the other members of the data structure that are initialized will be, see, the message queue number. Since the message is just created, the number of messages obviously present in this queue will be 0, isn't it? So it is set to 0. And when the message queue is just created, obviously no process has sent any message to the queue. Even that will be set to 0. Message receive will also be set to 0 because no process has received any message. Message send time and message receive time is also set to 0. And finally, the message change time is set to the current time. Okay, so these are the various members of the IPC message queue ID data structure that will be set when the message queue is created. Okay, and as previously mentioned, on success, the message get returns a non-negative queue ID, and this value is then used with other 3 message queue functions like message control, message send and message receive, which we will be looking into very soon. So this is about message get function. The next important function is message control function. Using this message control function, various operation on a queue can be performed. and this is the syntax of message control function, right? And it returns 0 if successful and -1 on error. So if I want to perform some operation on the queue, then I have to specify on which queue I need to perform the operation, right? So that is done by passing the message queue ID of the queue onto this message control function, okay? And the second parameter, command cmd, so this represents the operation itself, okay, that need to be performed on the queue specified by the message queue ID, okay. And the command can take the following values. So these are the various values of a command, and these are the various operations. So the first one is IPC_RMID. So using this the message control, if it takes the command value as IPC_RMID, then it removes the message queue from the system and any data still on the queue. So entire message queue will be destroyed by using this command in the message control function. And obviously it cannot be called by any function. It can be done only by the process that has the permission, or by the process that has super user privileges, okay. The next one is IPC_set. So this is used to set the members of the message queue ID data structure from the buffer, okay. Buffer in the sense, this is the buffer what I am talking about. And finally IPC_stat. So this is used to copy the members of the message queue ID data structure into the buffer, okay, into the buffer. And again this can be done only by the process that has the permission, or it can be done by a process that has super user privileges, okay. So this is about message control function. So these are the three operations that can be performed by on the specified message queue, which is that is done by using that is specified by message queue ID, that is passed as the first argument, okay. And the second argument, obviously as mentioned, it performs one of these operations, okay. And it can be done as I'll repeat again, it can be done only by the privileged processes or by the super user process. The next important message function is msgsnd function. So as the name suggests, this is used to place the data onto the message queue, okay. And this syntax goes like this. It will return 0 if successful and -1 on error. As you can see, it takes these arguments, and message send function will place a message onto the queue, and the identification of the queue is specified as a first parameter, where we pass the message queue ID, okay. And we all know each and every message is composed of a positive long integer type field, a non-negative length n bytes, which is represented in n bytes, and the actual data, okay. And messages are always placed at the end of the queue. So even though messages can be retrieved in any order, it need not be retrieved from the first in, or we need not follow the first in first out order of receiving the message, but the messages when it is placed into the queue, it is always placed at the end. And the PTR argument, so this PTR argument, the second argument, it always points to the long integer that contains the positive integer message type. So we will be looking about the message type very soon with an example. And it is immediately followed by the message data, the actual message that we want to store in the message queue, okay. And suppose if the largest message we want to send is 512 bytes, we can define the following data structure or following structure for the message. Yes, so this is the structure for the message, whose name is my message, and this is the type what I am talking about, and the pointer, the PTR pointer, will be pointing to this particular long integer message, positive integer message type, okay. We named it as message type, my type. And this is the 512 is nothing but the n bytes what we talk about. This is the size of the maximum size of the message, n bytes, and my text will actually contain the message what we want to store in the queue. Okay, now what about the flag? There is a flag field, right? So if the flag is name of the flag is IPC no wait, so if that is specified, let us see what happens. Okay, it is very similar to the non-blocking IO flag or file IO flag. Okay, if a message queue is full, either in terms of the number of messages that can be put in a message queue, or with respect to the total number of bytes on the queue, if it exceeds or if it is equal to the system limit, then specifying the flag, that is IPC no wait flag, causes the message send to return immediately with an error. Okay, if it is not specified, if this flag is not specified and the message queue is full, then the process that want to send the message is blocked until the room for message is obtained. Okay, so this is how the message send function work. So message send, as I said, it is used to send the message, and with the message queue ID I identify to which queue I have to send the message, and pointer points out to this message type, okay, to this data structure, to this structure rather, and n bytes defines the maximum number of data that can be that is present in the message, and flag indicates what operation need to be performed when the message is full. Message queue rather, not messages, when the message queue is full. Okay, so when the message send returns successfully, the message queue ID data structure associated with the message queue is updated to indicate the process ID that made the call, the time that the call was made, and the number of messages present in the queue. So all this data need to be updated in the message queue ID data structure after message send function is called by or used by some processes, right? Okay, so this is about message send function. The last function with respect to message queue is message receive function, and it is used to receive the message from the message queue, and the syntax goes like this. Message receive function is called by a process that want to read from the message queue, that want to read messages from the message queue, and it returns the size of the data portion of the message if it is successful, and -1 on error. Okay, and these are the various parameters that are passed. So let us see each one of these. So message queue ID, so this specifies to the message receive function from which message queue the message need to be read, right? So that is identified by the unique ID for the message queue, and it is passed as the first argument, first parameter. Then comes the pointer. So as with the message send, the pointer arguments point to the long integer followed by a data buffer of the actual message that need to be message data that need to be read. Okay, then followed by n bytes. So what is this n bytes? N bytes specifies the size of the data buffer. So it's the amount of data that it want to, that the process want to read from the message queue belonging to a particular message, right? And let us consider a scenario. So if this is 100 and the actual message is 200, or let me take it as 250, then what happens? So that depends on whether the flag bit is set or not. The name of the flag is message no error. So if the message no error bit flag is set, then the message is truncated. Okay, so what do you mean by truncated? The first the value that is specified is here is 100, right? So out of the 250 bytes of messages, the first 100 bytes of the message will be truncated and it will be returned to the calling process. Okay, and the rest 150 bytes of the message will be discarded. Okay, if the flag bit is not set, then the message receive function will not provide any messages to the calling process. So the message will remain in the queue, and error message will be sent to the process that calls this message receive function. So this is about n bytes. Okay, then coming to the type. Yeah, the type argument k can take the following values. So if the type is equal to 0, then the first message on the queue is returned. If type value is greater than 0, then the first message on the queue whose message type equals to the type is returned. So whatever the type that we mention here, that will be returned if the value is greater. If the value is less than 0, then the first message on the queue whose message type is the lowest value less than or equal to the absolute value of the type is returned. Okay, so normally we go with the non-zero type. We go with the non-zero type if you want to read a message in an order other than first in and first out. For example, the type could be a priority value if the application assigns some priority to the messages, right? So if you don't want to read a message in certain order, or if you want to read a message in based on the priorities of the message, then values will be set, priority values will be set to each and every messages, and based on that we will read the message. That is specified to the type, right? So based on that value we can read the message, not necessarily in first out order. Okay, now coming to the last one, that is flag. Yeah, we can specify a flag IPC no wait as same as what we used for the previous function, that is message send. IPC no wait is set if there are no messages to be received, right? So what happens? Let us see what happens. If a message is not available and if the IPC no wait flag is set, then it causes message receive function to return -1. Okay, and if IPC no wait is not specified, then the operation is blocked until the operation, in the sense I am talking about the reading operation, receive operation is blocked until message of the specified type is available in the queue. Okay, yeah, so that is about the flag. So this flag is used when the message is not available in the queue. So what need to be done when the message is not available? If the flag is set, then error message will be set to the sender or to the function that to the process that calls this function if the message is not present. If the flag is not set, then the process will wait until that message is made available, or the process is blocked until the message is present in the queue, it is made available in the queue. So this is about message receive function, and these are the various functions and operations that we can perform on message queue, with which we can have inter-process communication between multiple processes. I'll see you all in the next one with the semaphores and shared memory. Thank you.